Good morning. Welcome to the lecture session on bilinear transformation. In today's lecture, we are going to discuss some of the problems. Find the bilinear transformation that maps the points 1, I, minus 1 onto the points I, 0, minus I. The first points 1, I, minus 1 refers to Z points, that is Z1, Z2 and Z3. And the second points, that is I, 0 and minus I, refers to W points, that is W1, W2 and W3. So we will respectively name them as Z1, Z2, Z3 for the first 3 points. And for the next 3 points, we will name them as W1, W2, W3. So here it is, Z1 is named as 1, Z2 is I, Z3 is minus I, and W1 is I, W2 is 0, W3 is minus I. And we have the formula W minus W1 into W2 minus W3 divided by W1 minus W2 into W3 minus W. That is equals to Z minus Z1 into Z2 minus Z3 divided by Z1 minus Z2 into Z3 minus Z. And we have the formula and we have the points for Z1, Z2, Z3 and W1, W2, W3. So we can replace these points. Then we get W minus I into 0 plus I divided by I minus 0 into minus I minus W. That gives us Z minus 1 into I plus 1 divided by 1 minus I into minus 1 minus Z. That is, on simplification, we get W minus I into I divided by minus I into W plus I, which gives Z minus 1 into I plus 1 divided by minus of 1 minus I into 1 plus Z, that is taking the minus sign outside from the previous step. So in the next step what we get is, that is on cancelling a minus sign on both the sides and I in the left hand side, both the numerator and the denominator, we get W minus I by W plus I is equals to Z minus 1 into I plus 1 divided by 1 minus I into Z plus 1 or 1 plus Z. This is what we will be getting it. And further, we need to do the simplification. So on cross multiplication, we get W minus I into 1 minus I into 1 plus Z is equals to W plus I into Z minus 1 into I plus 1. So here is the multiplication in the left hand side as well as in the right hand side. So when we simplify the left hand side and right hand side, what we are getting is 2 times of W minus 2 times of WZI is equals to 2ZI plus 2. In the left hand side, we can take 2W outside, which gets 1 minus Zi, and in the right hand side we can take again 2 outside, so we get 1 plus Zi. That is, when we cancel the 2 on either side and keeping the W on one side, remaining all transfer to the other side, we get Iz plus 1 divided by minus Iz plus 1, or we can write it as 1 plus Iz divided by 1 minus Iz. We can also multiply its conjugate and keep the denominator without I. So this is the required bilinear transformation for the given points. Next example. Find the bilinear transformation that maps the points 1, I, minus 1 to the points 2, I, minus 2. Also, find the invariant points. So, as usual, we will name the points, first 3 points as Z1, Z2, Z3, and the second set of 3 points as W1, W2 and W3 respectively. And we have the formula W minus W1 into W2 minus W3 upon W1 minus W2 into W3 minus W is given by Z minus Z1 into Z2 minus Z3 divided by Z1 minus Z2 into Z3 minus Z. And replacing the points of W1, 2, 3 and also Z1, Z2 and Z3 respectively, we get the following equation, that is W minus 2 into I plus 2 divided by 2 minus I into minus 2 minus W, that is equals to Z minus 1 into I plus 1 divided by 1 minus I into minus 1 minus Z, which implies W minus 2 into I plus 2 by W plus 2 into 2 minus I, that is equals to, by taking the minus outside on either side, we get Z minus 1 into I plus 1 divided by Z plus 1 into 1 minus I. Here also in the denominator of the right hand side, minus 1 and minus Z, we have taken minus outside, and in the denominator of the left hand side in the second step also we have taken the minus sign outside in the denominator. So that minus and this here it will get cancelled. This on simplification, by retaining only the W terms in the left hand side and transferring the remaining I terms, that is I plus 2 to the right hand side denominator, 2 minus I to the right hand side numerator, which gets like this. That is W minus 2 by W plus 2 will give us Z minus 1 into I plus 1 into 2 minus I divided by Z plus 1 into 1 minus I into I plus 2. So this on simplification we get W minus 2 divided by W plus 2 will be equals to Z minus 1 into I plus 3 divided by Z plus 1 into 3 minus I. Again we need to simplify this, that is W minus 2 into Z plus 1 into 3 minus I is equal to W plus 2 into Z minus 1 into I plus 3. Now again we need to do the multiplication because we need only what is W is equal to. So let us multiply in the left hand side as well as in the right hand side. We can multiply by considering two terms and then again multiply with the third term because we are having 3 terms. But here we have already multiplied it in the left hand side and in the right hand side. On simplification in the left hand side, we are getting 6W minus 2WZI is equals to 12Z minus 4I. Again, in the left hand side, we can take a common factor, that is 2W. In the right hand side, we can take the 2 outside. Then what we are getting is 3 minus Zi, and here in the right hand side 6Z minus 2I. So the required W or the required bilinear transformation is given by 6Z minus 2I divided by minus IZ plus 3. So this is the required bilinear transformation. Here also we can multiply its conjugate and then get the denominator free from I, otherwise you can keep the result as it is. So this is the required bilinear transformation. Next, to find the invariant points, we need to put W is equals to Z in the equation. That is, Z is equals to 6Z minus 2I divided by 3 minus IZ. Cross multiplying and taking everything into the one side, we get minus IZ square plus 3Z minus 6Z plus 2I is equals to 0. It is nothing but a quadratic equation in Z. So by using the formula minus b plus minus square root of b squared minus 4ac by 2a. If we do that, we will be getting this result. That is, z is equals to 4 divided by minus 2i or 2 divided by 2i minus 2i, and we know that 1 upon i is equals to minus I. Therefore, we are getting z is equals to 2i or z is equals to I. That are the invariant points. Thank you.